Hey, what's up, guys? We've got some great footage today. We're going to be rewiring a 400 amp entrance for a transformer rated meter, something that we haven't yet seen on this channel. Stick around. So how this job all came about, we are currently going through a major meter swap, installing smart meters around the entire province. We've got some specially certified technicians that are doing all the transformer rated meters, power meters. That's the ones on 3-phase or a 400 amp entrance like this that's feeding a barn. Basically, there's multiple buildings on this property, all wired, all metered through this one meter. So everything overhead, like these wires going to that barn, are owned by the customer. So the fella called me up. He wanted to swap out this meter, and screen is blank. There's no power on this meter. So he did do a quick investigation. I should mention that there are some special courses that are required in order to work on these transformer rated meters, which I do have. Also, there are some CTs up on top of the pole, which we will look at in a minute. But you can see it says here, caution, service equipped with CTs, remove cover and open test switch before removing meter. As I mentioned previously in a video, you do not want an open circuit on CTs. You can see here he actually opened all the circuits already. So this is the test switch for our potential wires. Basically, we've got a red wire and a black wire that are tapped off of the two hots at the top of the pole. That way the meter will see whatever, say 122 volts on one hot, 123 on the other. And then we have these wires which are attached to the CT at the top of the pole. I should back up a bit. It uses the current and the voltage to come up with power usage. The amperage is so high in this property, it could be up to 400 amps, where it's brought down from a ratio probably 400 to 5 ratio, so there's more readable level with the amperage passing through the meter. Before removing this meter, if you have an open circuit on the CT, it can create an extremely high voltage situation. So when we open the disconnect here, we can see there is a shorting bar which connects this wire to this wire, closes the loops. There's no open circuit. So that's already done. There's no power at all going into the meter right now. We're going to grab a voltmeter here. So one of the first steps the meter reader took when he saw the blank screen was checking voltage. The source side is actually coming up through the bottom of this test switch. So if we check voltage on our red hot, we've got 15 volts, and on our black hot, we've got 124.7. So initially the call came through that we lost power on this one hot wire here. So we thought it may just be a matter of going up the pole and redoing that connection. But let's jump up the pole and have a closer look at things. Alright, so we're up the pole now, and there's quite a rat's nest of stuff going on here. Pretty hard to trace things out with your eyes. Where it is a 400 amp entrance, we have a double run of 1-aught triplex feeding into this pole. It passes through all of our metering and essentially comes back up and then distributes to each of the buildings. You can see that building over there, the home right here, we've got the barn over there. All that wiring belongs to the customer. The wiring involved for the metering, these little guys here, that belongs to us, the power company. So that's what I'm going to be looking to repair today. It became apparent pretty quick that we've got a break in the wire. You can see that one wiggling in the wind right there. And then there's also a second break in the weatherhead right up here, which it looks like this wire disconnected. So an easy solution would just be to reconnect those wires, but we've got a major problem here. All the insulation on those wires is bare. even going right up into where that's bare. So I don't even really want to shake this pole around too much. Those wires shaking around where they're bare, just small wires, but they are directly connected to each of the hots. So if they hit together, we're gonna get a pretty bad flash here. So we're gonna have to replace all that wiring, and we want to make sure it's hooked up in the exact same way. We don't reverse any of the connections or polarities, which would affect the metering. The second thing I do want to add, this is our CT right here. Something important with these window type or donut type CTs is, as this wire, this is the source, passes through, with the second hot, you want it to pass through in the opposite direction. So the second hot, they're crisscrossing each other, passing in the opposite direction. That way it allows for the currents to add together. So I've got the CT shorted out right now, but as soon as I cut those wires clear, we've got an open circuit again, regardless of the fact that I've got the circuit shorted out at the test switch. So there should be a shorting bar underneath this cap where those wires are hooked up. Before we touch these wires and open that circuit at all, the first thing we're going to have to do is cut that cap clear, short out that CT. Problem is, when I'm wiggling that all around, again, we've got all these live wires here. So I think what we'll do, now here's another problem. We don't want to reverse, we don't want to get these two guys mixed up. One of them is going to be a red wire with a white stripe. One is going to be a red wire with a black stripe. You can see CTs always have a polarity mark. Just that little white dot, that's the polarity. So basically that's the positive side. You're going to run your red wire with a white stripe on that side, but there should be a polarity mark under this cap as well. Pretty straightforward as far as our connections, but we also do want to make sure it's wired up where it's an older setup in the exact same way that it is now. So I think what we will do, for starters, we're going to clip these guys clear so we don't have that hazard of all that bare live wire coming through. And then once those are clipped clear, we'll pull that cap off and short that out, clip these guys clear as well. And I think we're going to try to pull one wire up through at a time and make sure we can confirm that this is going to be wired up the exact same way that it was tore apart. I'm going to need my two hands to do all this, so let's go strap on the helmet cam. I already stopped and met up with our meter guy to get some of this wire here. So we've got our black, that's for potential, our red for potential, and then we've got our white striped red and our black striped red for the two currents. This is number 12 solid copper wire. We're going to use these piercing connectors to hook up the two potential wires, and these guys are going to screw right into the window type CT. You want to make sure you bring up a screwdriver that's got a small end for that. The Lineman screwdrivers are quite large, and when you're working on the smaller electronic stuff. So these four items, that's pretty much all we're going to need up in the air. Now, as much as I would like to cut these guys all off right now, they are still alive, so we're going to start up the top of the pole and we're going to isolate all these wires before cutting them clear. We'll probably cut them over on this side so they're not tied to that. We're also going to remember that we've got red, black, white, black. A lot of times when I'm doing metering, especially three-phase where you've got way more wires than that, I'll actually take a picture of all the colors and their placement so I can put everything back in the same spot. New construction, we do have a standard with our red, yellow, blues and our red and blacks and whites. So new construction, pretty straightforward. It all goes in the same spot. But when you're redoing this old stuff, you do want to wire it up in the same way that it came apart, as long as there hasn't been any major code changes with how it's wired.
Heading back up into the air now, I just kind of repeat myself, I guess, but I do want to mention again, shorting out the CT is extremely important, and in normal circumstances, when doing a job like this, even before cutting those two potential wires, the ones going up to the hots, I would remove the cover and short out that CT very first thing. Problem is with this setup with all those bare wires, if anything wiggles around at all, I could get a bit of an arc flash. It's just small wire, but it's not fused, so it could be a fairly large arc flash actually. So we're going to eliminate that hazard first by clipping those hot wires. I'm not going to remove those piercing connectors, again, as it would kind of vibrate things around. So I'm just going to click those off with the Lineman pliers, removing that hazard, and then I'm going to short out that CT, which we will see in just a minute. I do have to be careful as well, where even though that CT is shorted out at the test switch, since that wire is broken at the weatherhead, there's a high possibility of there being high voltage produced by that CT with the open circuit. So careful, even though I removed those two hot wires, I'm being careful not to touch any of the other wires. That's the break going to the CT right there that I'm pointing out. But we're going to remove this cap. There is a seal on it. That's what I'm clipping off now with my pliers there. That seal's in place because it's not likely that a customer is going to climb up into a pole like this, but we've all seen stranger things. And if that cap is removed and that CT is shorted out, then it will affect the billing. So that's why that cap is covered. But the CT shorting bar, it's pretty small, hard to see here. There's just a little copper brass bar. We're going to loosen up the top screw, and that bar will swing down onto the bottom screw, and then we just tighten that up in place. So with the CT now shorted out and those hot wires cut clear, we've removed the two hazards that were in place. Everything on that pole is still energized, of course, so we do have to continue wearing our 1 kV rubber gloves throughout this job. There is no primary on the pole. So now that we do have everything shorted out, potential removed, we can remove the meter. And my next step here, this is all de-energized now. Normally I could just cut all these wires clear, probably use them as kind of a fish time off and pull the new wires down through. But the wires up top, the UV damage turned all the colored wires white. So I left the tails onto the test switch so we'll remember exactly how to wire them up. And on the top end, where I can't tell the colors, I'm going to grab a hold of the one going to the CT with my pliers and yank that out through the weatherhead where it wasn't exposed to the sun. And we can see that it is the red wire with the black stripe. And that particular one that was broken was going to, there's 3 connection points in that CT, it was going to the top one. So what I'll do when I run the new wires in, I'm going to wire back up the exact same way and use the red wire with the black stripe going into the top connection point of the CT. And same with the hots. Trying to remember now, I think it was the black one on the hot closest me, but at the time I had that memorized and also had the footage. A lot of times, as I mentioned, I will take a photo of how things are wired up when I'm rewiring so I can reference that photo if required. And what we're going to do here now, it's not a really long conduit to shove the wire through. If there was no wires in it already, I could definitely by hand just push them down through. But just to make things a bit easier, we're going to tie them off to the old wires. That way my partner down below can pull the wires down through as I feed them. If this was a long run, I wouldn't simply just be taping the wires together. You would have to actually, usually what we do is skin the wires back and kind of twist the bare conductor together to make a real good attachment point. And if, of course, you're pulling through hundreds of feet of conduit, you will want to use a proper pulling device, which I've never covered in a video, so we will check that out at some point for sure. That box, I know a lot of people are going to be asking, that gray box that kind of looks like a little mini transformer or something on the pole, that is customer owned, and it's a transfer switch. The feed goes down in through that box and back up through. At the bottom there is a plug that you see draped over top of the meter box, and there's a handle, a steel rod coming down the pole where the customer can operate that from the ground to disconnect from our lines. So I am going to take a quick break in the video. It's about 2 minutes for those of you that want to skip it, but I did tour across the US a couple of weeks ago. Wanted to show a few clips. I was real fortunate to check out the CensorLink facilities. All of their high voltage testing equipment, the amp stick, every single unit is tested on site. It's all assembled right there in Seattle. Later in the day, we climbed up this huge mountain. Yeah, I got warm. I took my shirt off, sorry guys. Met this gentleman here that was doing some painting, and finished off the day watching Logan do this epic first kick ever in his football game. We checked out the famous fish toss downtown Seattle and carried on for the rest of the evening with the gum wall. It was disgusting. You've probably seen some clips of this online before. This shot here, it's all the gas meter equipment, everything. It just, everything is coated with people's gum. It was disgusting. Flew down to California, saw the wildfires. That was crazy. We flew directly over top of the wildfires. And once in California, went to kind of a private expo. It was huge. Got to meet a ton of people in person that I've talked to many a times over the phone and over Teams meetings, virtual meetings. That's always one of my favorite things to do when traveling, is meet all these people. A lot of real great people, all the major manufacturers and suppliers, vendors. They were all present at this expo. It was really great to see Dragonware there as well. I wear a ton of their stuff. It's my favorite, our graded products. Looked at some new equipment by CensorLink and finished the day off flying into Texas. This was a little town called The Woodlands, I believe. As I mentioned, one of my favorite thing about traveling is the people. This was AJ. He's got a TikTok channel all about line work. Check him out. And we've got Todd, who introduced me to In-N-Out Burger, had lunch, and Josh, we sat down in San Antonio, had some drinks together downtown. And this is Richard. I sat with him for 2 hours just chatting about life. It's a great experience. We checked out the Alamo in San Antonio. Again, really cool. I learned a lot of history about the Alamo, I guess. I still gotta watch the video now. But let's get back into the video here. So we're just fishing the wires down through now. I probably should have removed that weatherhead cap at the very start. But anyways, no big deal. My partner down at the bottom is just pulling his wires through. Once he's got enough wire, I'm gonna put the weatherhead back on. Just clips in place there, keep rainwater from going down in there. Now this part's really important here, guys. So I am measuring out exactly what I need for wire to hook everything back up, but I don't want to hook anything up until my partner is completely finished working in the meter box. Last thing I want to do is him be down there working and heat up one of those wires on him. So even the CT, we're not going to do anything with these wires until he's finished. It'll only take a few minutes, so I'm not going to bother heading down to the ground or anything. Something I did notice once I looked on the other side of the CT, that's the polarity mark there. I don't know why there was a white dot on the other side, but the polarity mark was on the left-hand side, which kind of irrelevant in my situation because I am just going to wire it up exactly how it came apart. So a little bit of prep work here. I'm going to take the old wires out, and again, I did memorize that the red with the black stripe goes in the top, followed by the red with the white stripe. If this was new construction, then you just simply have to match up your polarity, which it does in this case. The red wire with white stripe does go into the proper connection showing the white polarity dot. So just confirmed that he has done everything at the bottom of the pole, just kind of measuring out all my wires so she can make the 2 hots. We're going to hook up the CT first. Again, we don't want to open that shorting bar just yet. One thing I can do now that there's no break in the wires, once I do have the new wires in place heading down to the test switch, there will be a closed circuit at the test switch even without the meter on. So once these 2 wires are on, I can open that shorting bar, which we will do in just a moment here. This is why I said to bring up a smaller screwdriver, not use the Lineman screwdriver, because it's just way too big for doing meter work like this. Want to make sure you don't over torque those screws. So put the cap back on, and there's just so this is the part you gotta make sure you open that shorting bar before you seal this up. If not, as I said, it will affect the customer's billing. So we just gotta flip that shorting bar up, tighten it into place. Now we're gonna put the cap on, which we will lock in place here in a moment. Our next step is to heat up the 2 potential wires. The reason I left those quick connects in place until I was ready to hook up the new ones is when you remove them, there are some marks in the wire that do expose live wire, and with everything being so close here, I just didn't want to have to remove them, tape it up, then remove the tape to install the new ones. So I left them in place to cover that hazard until the new one's installed, which I put them back in the same location, but I rotate them slightly because I don't want the teeth to bite through in the exact same location as the previous piercing connector. Just for the simple reason it might not make quite as good a connection. There are some shear bolts on those quick connects, which I cut that clip out because it took me like a full minute, but I used a wrench by hand after to snap those shear bolts off so that they weren't not over torqued. Just had to go down and get a wire seal. We have various types of meter seals for different applications. A lot of our metering stuff, there's tiny little holes in the equipment that we can run the wire through the hole and back around into the meter seal, and they're extremely finicky to use with rubber gloves. That tiny little wire goes back into the seal and locks in place. So if I come back here in a few years and that seal's missing, then obviously there'd be an investigation as to why that is. So now our final steps before we can open the test switch, close the test switch back in, which will open that circuit. We do have to have the meter on and in place. And before we do that, we do want to check to make sure we have good voltage now, but we only had that 15 or 16 volts.
20? 124.
So we've got our 124 on each side. We're just going to put things back together here. Put the meter back together. It's our metering technician there beside me, so he's going to document all the meter information and submit that. I won't have to do any paperwork on this one. Once the meter's back on, then we can close that test switch back in, and that CT circuit will be closed by the meter itself. Alright, so that's pretty much it, guys. I don't come across jobs like this very often at all. We actually have enough meter work, three-phase transformer rated meter work, that we have a guy dedicated to these jobs. This one here just kind of landed on my lap. Figured I'd get the cameras out. There really is a lot behind metering. I'll try and get a three-phase metering job on video one of these days, where we have PTs, CTs, three-phase, wire up, everything. That'd be some really good content. I think you guys would like that. Appreciate you guys stopping by. As always, be safe, and we'll see y'all soon.